Degrees of unsaturation. Before we begin solving our first full spectroscopy problems, we need one more tool in our toolbox. The degrees of unsaturation of a compound is a very quick piece of information to learn about a molecule, but also very important. In order to fill octets, a molecule must possess certain ratios of carbons, hydrogens, and heteroatoms. Different ratios of these atoms will result from the presence or absence of pi bonds and/or rings. The degrees of unsaturation of a molecule will tell us how many pi bonds or rings are present in the molecule. To calculate your degrees of unsaturation, you take the number of carbons in your molecule and multiply that by 2. You then add 2 to that value, and then you subtract the number of hydrogens in your molecule, add the number of nitrogen atoms in your molecule, and then subtract the number of halogens in your molecule, where X here stands for halogens. You then take all of that and divide it by 2. A simple mathematical process, but an important one. Do not memorize this equation. If you need it, it will be provided to you. Every degree of unsaturation corresponds to a multiple bond, a pi bond, or a ring. Remember that a double bond is one pi bond. Therefore, a double bond would correspond to 1 degree of unsaturation. A triple bond contains 2 pi bonds. Therefore, it would contribute 2 degrees of unsaturation. Now that we know what the degrees of unsaturation of a molecule is, let's get some practice in calculating it. On the slide is provided for you the molecular formula for some molecule. Pause the video and take a few minutes to calculate the degrees of unsaturation for this molecule. Welcome back. Let's see how you did. We know that the degrees of unsaturation for a molecule is calculated by taking the number of carbon atoms in your molecule, multiplying it by 2, adding to it the value of 2, subtracting the number of hydrogen atoms in the molecule, adding the number of nitrogen atoms in the molecule, and then subtracting the number of halogen atoms, where halogens are fluorine, chlorine, bromine, and iodine, and taking all of that and dividing it by 2. If we plug in the values from our molecular formula, we have 2 times the number 4, which is the number of carbons, plus 2, minus the number of hydrogen atoms, which is 6, plus the number of nitrogen atoms, which is 1, minus the number of halogen atoms, which in this case is also 1 because we have 1 chlorine atom in our molecule. Take this, divide it by 2. We do some arithmetic, and we find that this reduces down to 4 over 2, which is equal to the value of 2. So this molecule, whatever it is, has 2 degrees of unsaturation. What does that mean? That means we have either 2 pi bonds, or 2 rings, or 1 pi bond, and 1 ring. How do we know which scenario is the correct one? From just the degrees of unsaturation, we don't. We have to use other spectroscopic information to help guide us there. But as a starting point, this was an incredibly easy value to calculate, and it gave us a great deal of information. If we were trying to solve the structure of this unknown molecule, our final structure has to fit one of these 3 possibilities: 2 pi bonds, or 2 rings, or 1 pi bond plus 1 ring. It cannot be anything else. That brings us to the end of this webcast. To recap, the degrees of unsaturation for a molecule tells you the number of pi bonds and/or rings located in that molecule. To calculate the degrees of unsaturation for a molecule, you have to know the molecular formula. Either I have to give it to you, or I give you a way to figure it out.